All right, guys. Again, this is week 10 chemistry. What we're going to be doing is we're going to kind of take care of two birds, one stone today. We're going to be going over basically how to calculate and how to do the lab for, was it Unit 4, Lesson 5 or something like that. I think that's what it is. Thanks for looking at the page. Yeah, Unit 4, I think Lesson 5, as well as taking care of the in-person requirement as well as some of the other parts there. So today's lab, the way it's going to sit, and let me get rid of this little thing. If you have any questions, just so you know, I won't be able to see it right away. But what we're going to be doing is we're going to look basically at how many joules or how much energy it takes to basically create or remove energy. So, example, like if you're going to take water and you're going to start boiling and you start getting some more energy to it, you can actually calculate how much energy that actually takes, or how much energy it would take to do that. That's what we're going to be doing today. So you guys in front of the people here in person, just so you know, and you may want to go ahead and go into the class and get it. I have the study guide that I printed out and I gave to them, as well as I actually have the actual assignment that you need to get completed. And both of those can be in the class and you can print those out. So if you're watching this as a recording, go ahead and pause it now. Go ahead and download those and print those out or use those to write in, okay? But here in the class, everyone has it, so we're going to get going. Just so you know, most of the stuff we're going to work on right now is going to be in the student guide, not the actual assignment itself. So let's go ahead and start there. Now, in general, we're talking about like the changes of energy. There's a certain formula that kind of should jump to your forefront of your mind. Does anyone know what that formula is? Does anyone have it written down in their notes? I'll go ahead and wait, guys. Okay. When we talk about energy and what's needed, there's a certain formula that comes out. It's Q equals to MC change in T. Okay, this basically, what is the mass? It's how much energy is for the mass. What is the specific heat, which is C, and the change in temperature of what we're talking about. So like example, if it changes temperature relatively quickly, it'll have a lower specific heat, and so therefore it'll take less joules. If it has a high specific heat, then it takes more energy. Water itself is 4.18 joules over grams times Celsius. It's like a weird unit, but it's basically how much energy it actually takes. So we're going to be trying to basically calculate this. This is important because this will definitely be a calculation that you will see on the test, okay? Let's go back to this bad boy. All right. It's better for you guys. Is that better? Okay. All right. So this is what we're going to do. Looking at your student guide, go ahead and turn the page over to the second page. This is my leftover. Okay, there's going to be some data tables. We're going to go ahead and complete two of the data tables themselves. We can actually just do it because we're not doing it via the way they wanted you to do this, other than doing it virtually through the simulator, was they wanted you to get a foam cup. It's technically two foam cups. They wanted you to have a rubber band wrapped around one of them. The rubber band was going to basically help seal the two to each other. Then they were going to have to put water and ice inside of it, and then a thermometer inside of that. This is the problem with that. Doubt you guys are energy thermodynamic specialists. Anybody? I don't want to just totally disprove someone if they are. But in general, I've done the lab in person, without doing it virtually, through the simulator, and it's horrible. Horrible. Because you have two foam cups, which are fine, but then you have a rubber band separated. You have no way to really seal in, because you don't want anything from the outside really messing with it. You don't want the thermodynamics of the air or the air molecules to hit against it, because that can affect the temperature. You don't want that. So using this virtual lab, it allows us to basically simulate a perfect scenario. So we can just do one trial and be good. If we were doing it in person and we had it sitting there, we'd want to do 3 trials because we want to see how close it we get. We would assume by doing the 1 trial, we'd say, oh, it'd be that many joules. But the next one's like way off. You're like, okay, well, what happened? Let me do the 3rd time. And then you can see if there was a mistake or not a mistake made. And that'll help reduce the error rate, which will actually ask you that question on number 3 of your actual assignment. So, what's the first thing I need to do? Let's go ahead and look at the page number 2 of your heat transfer study guide. What's the very first thing it needs me to measure? Look at observations. What's the very first thing it's asking for? Perfect. So I take that and I set it down. Okay, so I went ahead and set that down. So wait, it's asking for the whole calorimeter, and so therefore I need to also put that on top of it. Okay, so calm down, Turbo. All right, so it's going to shudder a little bit for you guys on the internet, so I do apologize for that. But right there, you can kind of see what it is in grams of what the calorimeter is empty. What is it? 409. So go ahead and write 409 grams. Go ahead and write it down too, so when we do the math. Very good. Okay, so what I'm going to do now is I'm going to take off the calorimeter. I'm just kidding. I'm going to take the lid off. Can you grab me my mouse off my desk? Pretty close to the cherry on top. Okay. I'm going to just so you know, I'm going to switch over to another device to be able to get this because my pen is not awesome. Okay, so I'm going to go ahead and take the water, pick it up, and I'm going to go ahead and pour it in there. And then the next question is what is the mass of the calorimeter with the water inside of it? So I'm going to put that down. Now, what do I have to put back on? What do I have to put back on? I just added water to it. Is it the true temperature or the true weight right now? So okay, I'm going to go ahead and take the cap, put it right back on, and there you go. So go ahead and write that total that you see there in where it says mass of the calorimeter with water in grams. So if I've calculated what it is itself, and I just put water in it and weighed it, how much does the water weigh? What? Okay, so how much does the water weigh right now inside of this? What does it weigh right now? No, 459. 459. What did it weigh before I put the water in? So the difference would be the water. So write down. So what we did is kind of heard some whispers of it as I walked away, but basically what it is you know the calculations 459 for the whole unit, including the water. Then we know that the unit itself is 409. So you just minus the two together, and you'll remain of 50 grams of water. So go ahead and write that down. Okay, at the exact same time, I'm also looking at this, and I can get what the initial temperature is of my water. What is that? 21 degrees Celsius. Go ahead and write that down. Now, there's a couple ways you can get them. What's the next one I'm looking for? Okay. Okay, so just so you know, the mass of ice, there's two ways I can do it. I can add the ice directly into the calorimeter right now and just do math again. But this is the one thing I don't like about that, is that as soon as I put the ice in there, it will start to melt. In this case, it'll be fine if we can do this. But in some cases, it'll melt and start getting effects from the other parts of the environment. It doesn't give you a true representation. So we can do, also what we could do is just measure this, which doesn't allow us. We could measure this, then measure the ice, assuming they're the identical, and then do the math that way too. It does not matter how you do it, it's the exact same thing. So let's go ahead and put those on here. Go ahead and take this bad boy off. Take the ice. 44.4. That's the technical word for it. Okay, so I go ahead and do this. Now what is that total? With the ice also inside of it. Okay, so what I did is I just added a math. So do the math between the cylinder with the lid and the water minus what you see now. So 459 or 509 minus 459, which is, if you're stuck, let me know. The second one right there was the mass of the calorimeter with water. All I did is add ice. So the only increase in mass should have been from the ice. So you got to know the difference of that. So 509, which is there, minus 459, which is, help me out. Thank you. 15. And don't worry, as we stop this, once I stop recording, I can go through all these calculations again for people that don't quite understand that type of the math going on with that. Okay, it's not a big deal. It's just a concept. It's really just minusing two things, but knowing how or why to minus that's important. Okay, so the total one is the next one, which is 509, which is a little backwards, but we'll just write that down. So mass of calorimeter with water and ice is 509. Okay, we'll get to the next one in a second. Okay, what is the temperature? We just want to write that down. What's the temperature with the ice in there? 0. So you just want to kind of put that up to the side, okay? Just put final temp 0 degrees. Somewhere, it's not on the actual paper, just write it to the right outside somewhere, then you know what that is. Okay, let's see if I remember how to do this. Okay, what I did is I just poured out the water itself. Okay? I left the ice in there. But now the change will be different because there's ice that got melted to water. So we're going to make sure we calculate that. So let's measure the mass of the ice remaining. So if it's 444, we go ahead and minus that from the 509. And what is that? 55? No. 65? $65, right? Okay, and the mass of the ice that's melted would be, the math. Oh, I'm sorry, 65 would be the mass of the ice that was melted, I'm sorry. The mass of the ice remaining, you have to just basically look at what is it now, 444, and we take out and we minus it from the calorimeter itself, which was 409. I minus the wrong one, my apologies. So 409, what is it now? 444, so 36. I apologize for that. So mass of the ice remaining right now is how much more does this weigh right now with the container taken into consideration, which is 409. So it's 36. Oh, 35 is 9. Okay, so 35. So 35. And then the ice melted, what I just poured out was 65, which makes sense because ice didn't grow inside of this. It melted. And so we got rid of more than we have left. Okay, so Now that we have most of our calculations here, what we can do is we can actually start calculating out the actual joules and everything like that. And that's where the people from the internet, I'm going to be letting you guys go. The essential question that you guys will be turning in for this lab is going to be, basically, I want you to write inside the box itself of what is the heat needed to melt the ice. Okay, so you're going to be putting that in. That's the essential question. You're going to tell me, basically, you're going to be doing the next step in the observations, which is you're doing the calculations. I want that calculation written inside the comment box inside the class for week 10. So it should have a numeric value and joules. Okay? And then, so I'm going to let you guys go. We're going to go and work on that here in class and finish up the lab itself, because that's what the people who showed up in person are going to be doing. Okay? So the people on the internet, go ahead and make sure the essential question is, what is the heat needed based on these trials to melt the ice? All right? Let me go ahead and, someone had a question. The calorimeter is the whole unit. Some people have some questions online, so I'm going to answer them real quick. So basically what it is that the whole little thing that you see, the metal you see right there, that is basically, it's a meter to measure how many calories it takes for change, or how much energy it can change. It is a sealed container that doesn't allow for outside temperature to affect it. That's what this little, like, when you go right here and this little spinny thing that I'm doing right there, that's actually the ability for it to stir and be completely sealed still, so it does not have any effect from the outside temperature on it. And it allows for you to get temperature. Good that you answered that. What would be the mass of the ice remaining? I think I answered that. The mass of the ice remaining would be 35 grams. Would be the difference between what the temperature or the mass is now compared to what the calorimeter actually is. Yes, you want to answer you're going to go into the Dropbox, into the comment section, and you're going to type in the answer there. Yes. And so you should be able to calculate that now. So are we good? All right, for people online, go ahead and I'm going to stop the recording. Go ahead and make sure you go and answer that question. And I also did about half the lab for you. So if you want to complete the lab at home, make sure you go ahead and go to the virtual lab, and you can use the same exact simulator as I'm doing now and finish out your trials.